climate change. So let me give the floor then to Professor JohnE, and of course, if you have questions, comments, you are invited at the end of his talk to participate. Thank you very much.
Thank you very much, Ricardo, Mario, and Roberto, and thank you for making the effort to come to listen to my presentation this morning. I hope that I will give you something to make that effort worthwhile, and I hope that you will also share some of the key messages that I provide today with other people. As our three introductory speakers were saying, this is a challenge that goes beyond the individual. It goes beyond the group. It is involving everybody, and the more we talk about it and share our thoughts and our commitments, the more we can succeed in addressing this particular problem. I also want to acknowledge the university for this invitation today. It's a real privilege to be here. We have, as has been indicated, a very special friendship and professional relationship with with Marcello, and also with his wife, because this is where they spent part of their honeymoon with my wife, who's the only lady with the white hair, so she's very easily recognized. But I also want to acknowledge where we are. In the Pacific, the indigenous people have this very strong link with place, their land, their ocean. And here in Europe, and especially in Italy, we understand the strong link with the history and the place. And I've had the privilege of a very quick description of the history of this room where we're meeting. And I'm very honored and very humbled to be having the opportunity to speak to you today in such a wonderful venue as this room. As Mario said, I'm going to be talking about the South Pacific, not because it's just important for you to have some insight as to what's happening in the South Pacific, but because there are messages coming from our experience in the South Pacific that are very relevant to Europe, very relevant to Italy, very relevant especially to the coastal areas of Italy. We share the same ocean. We share the same challenges of living in coastal areas. We don't share the same size population. We don't share the same land area, but we share the problems. And so because we're experiencing these problems now, then what we are learning has relevance to coastal Italy. And I'll end my presentation by explaining that. So I'll just give a very quick elaboration of why what we are learning from the Pacific is of relevance in terms of understanding climate risk. I'll talk about the issue of managing those risks in small island countries, the methods, and I'm going to make it very practical by presenting 4 case studies. And each of these case studies has learning and experience that's of relevance to coastal Italy. And then I will make that direct link back to Italy in terms of the relevance of what we have learned in the South Pacific to your managing the coastal challenges of climate change in Italy. Just a very quick introduction to the Pacific. It's a huge area of ocean with very few areas of land. You can see that we have in the South Pacific 3 main types of island. We have the high islands, we have the raised coral islands, and we have the atoll islands of the Pacific. These are low-lying little chains of islands around a big lagoon. So we can summarize it by saying it's a small land area in a large ocean. And you can see there the contrast between the various island types and categories, where we have the largest island with country with the largest population. We have other mid-sized, and we go right down to the smallest island of Wallis and Futuna with very small population. But on average, you can see that the population is very small, but the ocean area, the exclusive economic zone, is very large. And we can compare that with France. France, you can see there, has a land area of, and this includes its territories, of about 0.6 million square kilometers, a EEZ of 11 million square kilometers, but we have a land area of very similar to that of the total area of France. But look at the size of our EEZ, the 27 million square kilometers of EEZ, so twice as large, over twice as large of that as of France. The population of these Pacific islands varies from 5 million down to 66 people. And that highlights a real challenge of the social consequences of this issue of climate change in the South Pacific. So I use this to illustrate the Pacific Islands are something like that when we would do, or in previous times of using a canary in a coal mine to say whether there was very dangerous explosive gas in that coal mine. If the canary died, then the miners knew that they should vacate very quickly because there was a high risk of explosive gases or carbon monoxide, carbon dioxide levels. And the Pacific Islands are very much like that. They're telling us what's happening now, because that is really what is going to be the future of larger countries like Italy. So in this area of the South Pacific, we have in parts of the Pacific, we have observed rates of sea level rise, which are about 4 times the global average. So again, if we're experiencing already very high rates of sea level rise, there has to be lessons being learned there which are of relevance to people in larger countries like Italy and in larger regions like Europe. Most of our islands are, of course, coastal. It's only in Papua New Guinea, the larger islands of the Pacific, that you have areas that are significantly far away from the coast. In the Pacific, we have very high rates of population increase. And of course, it's not just what's happening in the natural world and the physical world that's important. It's what's happening in the demography and the society more widely when we talk about the consequences of climate change in coastal areas. The ecological and socioeconomic systems are very small, and so they're very sensitive to these changes. They respond very rapidly. There's very little inertia. There's very little storage capacity to get us through these volatile times. Pacific people traditionally have a very high coping capacity. They've lived with extreme events in the past. They've survived those extreme events. Their construction types are such that they can rebuild rapidly using natural materials. But of course, they have a very low ability to adapt because they don't have a lot of financial resources. They don't have a lot of technical support to get them through these changes. So again, you have that sensitivity, which means that we're learning lessons now that will be relevant to you in the future. And one of the very, very important messages from the Pacific is that the whole future of people living on their islands is under threat. There are recent studies to show that with the changes that are coming through high sea levels, stronger tropical cyclones, bigger ocean waves that will wash right over these low-lying areas, both in coastal areas and whole islands, that we have this problem of the future of life on these islands being under threat. So what are the changes that we can anticipate going into the future in the Pacific? They're very similar to the changes that you see happening and projected around the rest of the world, but they're happening at a faster rate and more significant. I mentioned tropical cyclones. These are the hurricanes or typhoons, depending on where you are in the world. They're all the same thing: hurricane, typhoon, tropical cyclone. And you can see that they are projected to intensify, become stronger in terms of the winds, and also stronger in terms of the rainfall intensity. Sea levels, as I said, are likely to rise or anticipated. El Nino and La Nina, the ENSO phenomenon, this is large swings that are in climate and sea surface temperatures and then rainfall that exist in the Pacific and have global repercussions, but in the Pacific where they originate, they are going to have huge impacts into the future, although one of the things we struggle with is the uncertainty, our inability to actually say what is exactly going to happen going into the future. And another challenge for the Pacific is the warming of the oceans leads to the dying or the death of the coral. And coral is an absolute building stone. It's a foundation of our islands. And if we, as a result of these higher temperature events, have the situation of the coral being unable to recover from these episodic high temperature events, that's going to be very, very problematic. And then we have reduced oxygen levels that are going to affect coastal fisheries. Another major challenge in the Pacific and indeed all ocean areas is that of acidification. We're releasing huge amounts of carbon dioxide into the atmosphere. A lot of that carbon dioxide is absorbed by the oceans, but that leads to the formation of carbonic acid. So the oceans are acidifying, and calcareous organisms like coral, but skeletal organisms like fish, have great difficulty in growing in these increasingly acidic conditions. And that will have a huge impact on the marine and coastal ecosystem. So cyclones are also likely to move poleward. So areas that have not experienced these high intensity storm events are likely to experience them in the future. And wave heights, as a result of increasing strength of the winds in the Pacific, especially associated with the tropical cyclones, are going to be higher, and this on top of already high sea levels is very problematic for the Pacific islands. And finally, these changes in rainfall, changes in wind, changes in sea level, changes in the wave climate is going to lead to increased coastal flooding. And it's these extreme events which are going to challenge the future habitability of these islands. It's not the gradual changes in sea level. It's not the gradual changes in rainfall, not the gradual changes in temperature. It's the change in the frequency and intensity of these extreme events, which is going to challenge habitability. So we've been obviously doing a considerable amount of work to understand these risks that we've just characterized and to determine how best to manage those risks. And we've developed quite a robust methodology, and I want to just run through this quickly because it really frames the case studies that I'm going to present in the next slides. We've been talking about these hazards as risk events, extreme winds, high sea levels, and so on. And we need to be able to characterize those, not only for the current situation, but we can learn from the past, and obviously we have to look into the future. We need to know how important elements of our society, of our ecosystems are exposed to these extreme events. We need to assess the vulnerabilities of those components. Again, our society, our economies, our ecosystems. What are the consequences of those extreme events? And then by combining that analysis, we can assess the risk, because risk is made up not only of the hazard event, but how that is being experienced and how the consequences are occurring. And only then, with all of that information, can we talk about managing those risks. And we need to look at that in terms of the costs and benefits of managing those risks. We can't manage all of the risk. We cannot manage 100%. So we have to focus on those risks which are beneficial to manage in terms of the relative costs and benefits. As I said, I'm going to share with you the learning from 4 case studies. And the first one is at a basin scale, where we're looking at the interconnectedness of the real world. And there's some very important lessons when we recognize the links between the physical and the social and the economic situation. And that comes at a basin scale. So even in a small country like Fiji, we do have river basins, and we do have that interaction between the biophysical, social, and economic. I'll talk about an area or site scale in Samoa, and then again about site scale in the Cook Islands where we live, and finally talk about the living shorelines as an approach, some learning, important learning coming from that, also using an example from the Cook Islands. The basin scale, this is Nandi in Fiji, and you can see the interaction between the various biophysical, social, and economic components. And earlier this morning, when I had the honor of meeting some of the research students from the university, we were talking about the importance of subsidence, the land sinking, because in a delta, which is what we have at the interface between the land and the ocean, we have a delta, and for various reasons that delta is subsiding and therefore exacerbating the actual phenomenon of sea level rise. So relative sea level rise is increasing at a much faster rate. So we have to consider all of those components, and this is where the complexity of the problem becomes very apparent when we're dealing with a basin-wide analysis, but also the uncertainties become apparent because we don't have a good understanding of all of the interactions that are going on there. And you can see a very, very important point is that we're dealing with a changing environment. The environment of this river basin, as indeed anywhere in the world, is changing. Even if the climate doesn't change, we're dealing with a changing situation. Climate is adding to that complexity of change that's already occurring. And one of the important messages there is that human habitation is increasing the risk because people are moving and establishing settlement on a subsiding basin, a subsiding delta, I should say, regardless of any changes of the climate. But then when you start thinking about the future, as that bottom panel shows, we can see that with all of the social change, the economic change, but then the biophysical change, we have a major increase in risk. And this is what happens when you live in a coastal deltaic environment in the Pacific with tropical cyclones, huge storm surge bringing high sea levels onto the land area, blocking the drainage from the mountain. But look at the color of the water. Huge amounts of soil coming down from the inland area because you've had deforestation. So that human actions are exacerbating the problem. And that's where we have to look at the linkages between the social, economic, as well as the biophysical systems. And we can start analyzing. The past is a very, very important source of information. We're not just looking at the present and looking into the future. We need to learn from the past. Absolutely important. The past can tell us so much. And the past is telling us in the 100 years from 1870 to 1970, we had 30 major floods in that river basin. But look at the last few decades, 50 floods for a total of 84 floods. The people in this river basin live with floods. They have become so used to those floods that's almost a way of life for them, but it's getting more and more common. That's the message to come from the previous slide. We can do the analysis, and I'm not going to go into a lot of detail about this, but those of you who are statisticians and love numbers, my presentation will be going up on the website for the university so that you can explore these in detail. But the message coming out of that analysis is that while the flooding has been increasing, the heavy rainfall events associated with the flooding have been increasing from over the last decades. Those increases are going to continue into the future, but we don't know exactly what the future is going to be. We don't know whether greenhouse gases are going to continue to increase in concentration in the atmosphere at the rate they've been doing over the last few decades, or is a miracle going to happen and we're going to reduce that rate of greenhouse gas increase? But we do know that regardless of what future scenario we adopt, that those heavy rainfall events are going to increase into the future. We also know that those high sea level, extreme high sea level events that have occurred in the past are going to increase into the future. And we can look at that by comparing the baseline for 2055 and those high sea level events, which are rare today and in the past, are going to be something that is a common event going forward. We can then look at the exposure. Remember that methodology circle that I was showing. And this is the flooding for a 100-year event, you can see that virtually all of the habited area is underwater, and very small islands of population where there's settlement are spared from that flooding. We can look at the impact on the overall area and see that the population affected, for example, is huge for a 100-year or a 50-year event, depending on our analysis. We can look at the costs of it, because we, as I mentioned before, we have to look at the relative costs and benefits of our interventions. And we can look at the damage losses. And you can see that while we have numbers for various situations, I want to draw your attention to how the number of people affected can be reduced by providing early warning. So people can then evacuate, they can take precautions. And this is a very important message that I'll come back to in terms of the relevance for coastal Italy, the importance of early warning as a method of reducing damage, losses and costs. So what are some of the risk reduction measures? We can get into the engineering. We can do a lot of engineering to assist in the movement of water from the inland areas out to the ocean, rather than having the whole area become a flooded basin. But the really important information is, again, we can undertake improved early warning measures and reduce the impacts with a huge benefit to the human population in terms of loss and displacement. The second case study, as I mentioned, is looking at the site scale. And this is in Samoa, and this is the parliament building for the government and people of Samoa. And this building has suffered extreme cyclone damage, largely because it's on a very, very exposed part of the main island of Samoa. You can see the lagoon, and further to the right, you can see the ocean. You can see the damage that's been caused. It's not only the wind damage that's damaged the roof, but water damage, storm surge coming right through the building. And of course, this has symbolic importance. It's not just its physical importance as a structure, it's its symbolic importance as signifying the resilience and future of the country of Samoa. So, highly vulnerable. Remember that term we were talking about? We have the risk and what is the response of our assets or our people to that particular hazard. There's going to be increasing vulnerability over the 50-year nominal lifetime of any new building. And the important challenge there is to manage the risks of the site versus the risk to the actual structure itself. And finally, how to manage the unacceptable risks, risks that really, because of their significance, we have to change the design and construction processes. So we can go through a very high-level categorization of our approach to risk management. We could relocate that Parliament building to a less exposed, less vulnerable location. It seems the obvious thing to do. But Samoa has had a Parliament building at that location in traditional times as well as post-European settlement times. So the chiefs would gather in the same location and talk about the governance of their tribes and their community and so on. So this location has tremendous cultural significance. So when we broached with the government of Samoa, should we relocate? They out of the question. Absolutely not for any discussion, whatever evidence we came on the need to relocate or the benefits of relocating. Should we protect each building? You can do that. Engineering gives us the ability to protect each building. We can put it on a higher pedestal and raise it above the flood level. We can make it strong so wind damage won't occur. Or should we protect the whole site? And that was a big question for us as people who were advising the government of Samoa and the development agencies who were providing the financial assistance. So we were faced with a challenge to prioritize the risk reduction options. What was our advice to those who didn't understand all of these issues of sea level rise and storm surges, but were having to make the decisions? So we undertook a cost-benefit analysis, because as we were saying in our discussion before, this is a common language. This is not only a language now of climate change adaptation and disaster risk reduction, it's a language of the financial sector for many decades. But we can also, and we have to, when we look at prioritizing risk reduction options, we have to think about the cultural, aesthetic, and other considerations. We cannot simply rely on a strict economic analysis of the costs and benefits. Now, to do this work, we undertook quite a complicated modeling exercise, and again, I'm not going to go through the detail. You can look at this at your leisure if you want to download the presentation. But basically, what we're doing is modeling the hazards and the consequences of those hazards over time, and then changing the design of our structure or the protection of the site, and determining, again, the economic benefits relative to the costs of those interventions. One of the things that we have to do in that sort of approach is to look at how the damage changes depending on the water level that the building is exposed to. Obviously, if the water level is low, the costs damage costs are very small. They escalate rapidly, and then by the time you're virtually overtopping the building, then there's no real increase in damage costs. And so we were able to model the damage costs through to the 50-year lifetime, or nominal lifetime of the building, and look at how those would escalate as sea level rose, waves increased in height, and so on. And then we could look at the costs of reducing that exposure using the various interventions of raising the platform, increasing the strength of the construction of the building, and the like. Again, I'm not going to go into a lot of details, but what we could do is, in the end, say that if we raise the height of the building above mean sea level by these numbers of meters, 2.8 to 3.2, we could look at the reduction in damage costs and calculate an internal rate of return. This is the cost relative to the benefits delivered. And you can see that there's a very, very high rate of return. This is a very, very good investment, especially if you take out those initial events which are much more common and you don't have the construction costs to incur. So looking at the damage costs, looking at the reduction in these costs, and looking at the net present value of those damage costs, and finally the internal rate of return. We can also protect the site by building seawalls around the whole peninsula. And you have to provide the decision makers with that option, as well as the option of raising the height of individual buildings. This obviously has benefits not just for the Parliament building, but for other people and structures within that area that you're protecting. And so again, we looked at the costs and relative benefit of protecting the site and coming through with the same analysis. And if you go to that last column, you can see that the benefits, the rate of return, in other words, if you invest this money, what's going to be your return on that investment is much lower. So one of the conclusions was that based on the cost-benefit analysis, it was much more effective to raise the site of the individual buildings than to protect the area as a whole. And I'm pleased to say that earlier this year, the new Parliament building was opened, and the government of Samoa now has a climate-resilient Parliament building, thanks to the generosity of the people of Australia who funded the project. The third case study is to look at a site scale in the Cook Islands. This is part of our northern coast of the island of Rarotonga that you saw in the first slide. Here is our international airport. That airport is capable of landing 747 aircraft, the jumbo, but those aircraft can't take off from that airport fully loaded with fuel and cargo because they're too heavy and they wouldn't get off the runway in time. So we now have 777s and 787s coming in on a daily basis from New Zealand. This is our harbour, the commercial harbour on the right-hand side, and that's going to be the focus of my case study. In this instance, this is looking towards the harbour, and you can see we're on a high volcanic island. And the common perception is that on a high volcanic island, coastal risk is low, or if it is high, you can live with it by moving inland. But look at the steepness of the terrain. You've got nowhere to move. That harbour is fixed there. It has to be managed in its present location rather than moving inland. This is the result of a tropical cyclone in the 80s, and you can see the devastation, the flooding that occurred as a result of that tropical cyclone. So one of the big risks for that harbour is, in fact, the huge increase in wave height and also sea level rise, giving these very damaging events, as well as, of course, wind damage itself. So this is the result of looking at those risks and then deciding how best to redevelop the harbour. And there are two important dimensions of this response that I want to focus on. One is that the harbour has been climate proofed in order to allow it to operate with current and near-term conditions. So you can see that the wharf area the height of the wharf area has been increased by 0.5 metre, and it's been made more resilient to the increased power of the waves so that there isn't the resulting risk of damage. So we call this climate proofing. It's to allow that wharf to survive and operate today and into the immediate future. But the problem is, we also want to, in a reconstruction exercise like this, investment like this, to make it ready for the longer term future. But there is the challenge. We don't really know what that longer term future is going to be. Is the sea level going to continue to rise and the storms continue to be increase in strength as they have over the last few decades? Or is it going to be worse, or is it going to be better? We don't know. So the second part of the project was to make the wharf climate ready. And the main part of that was that the wharf structure was built strong enough that you could add another level of wharf on top of that if sea level rise increased at a rate that necessitated making it even higher than the current design. So climate proof, present day, climate ready, but acknowledging the uncertainty into the future. The final case study, as I said, is looking at living shorelines. And why do I want to focus on this as a case study? And again, this is experience from the Pacific that is highly relevant to coastal areas in Italy as well as wider Europe and beyond. And that is that we have had failure after failure when we've used hard engineering approaches to coastal protection. And even that goat on the upper right knew that that seawall was bound to fail, but the human beings still invested a huge amount of time and money in terms of that protection. We now know that there are many other options to coastal protection than simply the engineering option. And what I want to show in the right-hand side of this diagram is that as you undertake more and more engineering-based approaches, your costs are going to increase. And so if you look at the top where you're dealing with more the natural approach to coastal protection, your costs are relatively low. And experience shows that if you go into the green or softer approaches such as living shorelines, your ability to protect that coastal area can be increased. So there's a lot of learning, not only, of course, in the Pacific. This is out of the this actual diagram is out of the United States. This is another of our volcanic islands in the Cook Islands, and you can see there it's very small, it's virtually all coastal, and you can see here the type of shoreline, because this is a raised coral island. It's the coral reef system that exists on a top of a mountain that goes 5,000 meters to the ocean floor. So it's just the tip of that island, of that mountain, that's poking out above the sea, and the coral has built up on that mountain top when sea levels were much higher in previous geological times. So again, you can go through that process of hazard and risk assessment, and this is the calculator that was used to identify how best to approach the coastal protection interventions or investments, depending on what your analysis showed. In this case, the important example was that looking at how exposed this coastline is going to be in 2030s, as a result of sea level rise and the strengthening of the ocean swells and storm surges. And then if you look at the red line, this is in the 2060s, again, you're going to be losing quite a bit of the coastline where the habitation is located. And the analysis of the adaptation options, the risk management options in this case, was to use the planting of natural vegetation to provide that protection. And this is an example of that active planting and restoration of that coastal vegetation to provide protection for the human settlement, the housing and other buildings which lie behind it. So, in conclusion, I just want to run through some of the important lessons that we've learnt in the Pacific as a result of managing these coastal risks that I've identified. And one of the important lessons we've learnt is that you need to focus not only on the long term, but you need to manage for the short term risks. If you just use one or the other, you're going to end up with suboptimal interventions. In order to understand future risk, you have to have a very good characterization of current risks, because future risks are incremental on terms of your current risks. Managing the coastal risks, be they to the natural environment, to the human environment, you need to start early in the project cycle. When we got involved in that Parliament building, the architects and the engineers had already done all of the design for the new Parliament building. And then somebody in Australia said, well, what about climate change? And they had to go through and completely redesign and re-engineer that building as a result of the information we provided, adding incredibly to the costs of the project. Not in terms of the ultimate adaptation costs, but to the actual design costs of the building. So starting early to make sure that climate change is considered is very important. Decision making, the decision makers, government or private sector or community leaders, if they have good information, they can make good decisions. If they lack that information, their decisions will often be far from optimal. And finally, we have huge uncertainties in the future climate. And so one of the big challenges, as we were saying earlier today, is to help decision makers understand these uncertainties, not to see them as a reason for doing nothing and saying, oh, well, let's wait until the uncertainties are reduced. That is not an excuse to do nothing, but to make sure they understand the uncertainties and then make decisions which are informed not only by the risks, but also the uncertainties associated with those risks. And think about the difference between climate-proof harbour and a climate-ready harbour. There's an example of how we advise decision makers to optimise their responses, not build a harbour that's right for the next 100 years, but build a harbour that's right for today and the next 20 years, but then have flexibility to improve its resilience into the next 100 years. There's some good practices come out from the Pacific, which again have relevance. And that is, think of that circular diagram I showed you, starting off with a hazard and coming around the exposure, vulnerability, risk, and then risk management. And it's that seamless projection is so important to understanding how to get good results from the risk analysis and risk management. Risk screening is incredibly important. We're faced with so many risks and so many complications and interactions that looks like it's hugely complicated, and risk screening is an approach that allows you to identify which are the major risks, which are the risks that can be managed, which are the risks that you're going to have to live with, which is another challenge. Uncertainties need to be quantified and reflected in the guidance that you give to decision makers. It's no good hiding the uncertainties and hope that you can get away with it. Those uncertainties will come and bite you later. So you have to manage the uncertainties just like you manage the risks. Cultural and aesthetic and related factors are incredibly important, not just in the Pacific, they're important here. Look at your culture and your aesthetics here, which are incredibly important to reflect that in the decision-making process. So, hopefully this will justify your patience over the last hour. There's some real lessons of relevance that I've referred to as we've gone along, but I just want, in this final slide, I just want to come back and highlight them. The first one is the importance of early warning. And early warning is not just a humanitarian, it's an economic benefit as well. You can see there, according to this very high-level Global Commission on Adaptation, just issued a report a couple of months ago. They say that if you have 24 hours warning, you can deliver benefits of up to 30%. That's a huge cost-benefit situation. Climate resilient infrastructure and structures. Here, again, for every dollar you invest, the evidence shows that you will get $4 in return, building that resilience. There's a need, as we've seen, if we think about that basin scale example case study I started with, and it's not just what's happening at the coast, you have to think of what's happening in the interior of the catchment. Protecting and restoring forests and other surfaces and watersheds is incredibly important. Marcello showed me yesterday or the day before. Before we came here, we had the privilege of being in Monterosso for a few days and wandering around there. And I was thinking about the exposure of that area to coastal, to the ocean, not thinking about exposure to hazards coming from the interior. And Marcello showed the results of the 2011 flood event. Unbelievable. And of course, if you aren't managing your watersheds, you're going to increase those risks and the consequences. Restoration of watercourses and green spaces and increasing the porosity of your surfaces will have huge benefits in terms of coastal flood risk. And then restoration of wetlands so that they can be a very important buffer between the land area and the marine environment. So those are just a few transferring of messages from the Pacific to coastal Italy that is hopefully relevant. So I'd like to thank you very much for your patience and tolerance, including listening to my English. I apologize that I can't deliver my talk in Italian, but I was comforted by my three colleagues up the front who also spoke in English, so that made me feel a little better. But thank you very much. My email address is there if you want to communicate, but this presentation will be on the university website and available to you. So some question and answer if we have time. Thank you.
Okay, thank you very much, John. So now if there are questions, comment, curiosities to ask to John, John is available to answer. Alberto.
Thank you very much, Alberto Monti. We met just before. Thank you very much, John, for your enlightening presentation on this very urgent problem that we're facing and the perspective of the South Pacific Islands on that, which of course are on the front line, as you properly explained. The example of the Samoa parliamentary building is particularly stimulating to me for a number of reasons. The first one is that it clearly shows the problem also of the resilience of local governance capabilities. Right? It's a symbolic building because it's the building where decision makers make their own decisions. If the building is not available, decision makers don't know where to gather in order to make the decisions. So my question here is, to what extent local governance capabilities are, let's say, an area of focus in the climate resilient efforts of the South Pacific? The examples you've given us seem, at least to me, to be examples of international aid in terms of international technical assistance and international financial support to climate resilience projects. But to what extent there is a focus also on the building of local climate governance at local level. Mm. And the second question I have, which is also on the Samoa building, then I will quit, is the following. You gave us a very good example on how to use cost-benefit analysis to drive decision-making, right? That was a very clear situation where the return on the investment was the driver of a decision on whether to protect the individual buildings or the site. The problem, however, is that cost-benefit analysis requires the ability to determine what is cost, right? And determining what is cost is not that obvious. You mentioned, for example, in one of your slides, that the cost of one of these events could be measured in terms of the reconstruction cost of the building. But this is, of course, just one possible view, right? You have the historic cost of the existing building stock. You have the cost of building something different from what you had before, exactly in terms of adaptation. And in Italy, just to try to translate the problem into our local situation is even more difficult, because what is the cost of the Broletto building, right? How can you rebuild it back as it was? It is impossible, right? So the cost of the cultural heritage in Italy is something very difficult to assess, which is an issue that you briefly touched upon when you referred to cultural issues, but it's seen from a different angle, because it's not just the site where the building is located, but the building itself. Thank you.
Thank you very much for two really important points, because they add to the lessons that I want to convey today. I did focus on sort of the more technical aspects of addressing climate risk in the South Pacific. There is a whole other, well, there are several, but there is another major effort going into strengthening governance at the community level, right up to the national level, and further beyond that to the regional level, so country to country cooperation and collaboration. I didn't talk about that because this is not my area of expertise, but one of the important learnings in terms of building and strengthening governance in the South Pacific is that while it's absolutely necessary to have good governance, it won't in itself lead to good decision making, because those people, generally speaking, lack the understanding of the complexities, the uncertainties, and the emerging hazards that they're going to have to deal with. So the lesson that's come from the governance is the need to bring together the technical analysis and the decision-making processes and ongoing governance processes. They must work in tandem at all levels, right down at the community level, up to national and regional level. I'd be happy to talk more about that or send you some references. The second one, talking about cost-benefit analysis, you're absolutely right in terms of the challenges of taking a cost-benefit approach to issues like heritage buildings. It's in one way, it's totally inappropriate. It's similar to the problem that if we talk about the value of a human life and include that in our cost-benefit analysis, I have great difficulty putting a dollar value on a human life and then scaling that up to say, well, in this flood event, 100-year flood event in 2030, we'll have so many lives lost, so that's the damage costs for so many dollars. So again, it gives the decision makers, cost-benefit analysis provides one small insight for decision makers, but it is far from adequate just to leave it there. One of the things we've found is that the development partners like Government of Australia or UN agencies, World Bank, Asian Development Bank, they are much more driven by the economic analysis. And unless you can show a business case, they won't invest. So this is where we have this, I'm going to use the word unhealthy, frustrating situation of reliance on cost-benefit analysis to provide a business case, when in fact it's much more complex, as you've just rightly shown. Yeah, thank you.
Okay. Any other question?
Yeah, I have a question about your engagement with the IPCC. You talked about a minority of people, especially who are facing the effect of climate change caused by a minority of very rich countries, and who are still causing most of emissions, who are responsible for most of emissions. I'm thinking about CO2 emissions per capita, so I'm thinking about US, Canada, Europe. So you've been involved in the IPCC, and I'm trying to get people to react to the fact that we have a moral duty to take action, even if we here in Italy, for example, we have the resources to adapt to climate change, but there are millions of people living in other areas where they don't have the resources, or they don't have a chance, because their island is going to essentially be completely overflown. So what can we do to convince people that the problem has to be to convince the rich nations that they need to act, even if the impact on them, on their citizens, is in some way manageable, but they have to do it because, I mean, we can use moral persuasion, but maybe this is not enough, or it doesn't look to be enough. What else can we do?
That is a huge question. At the start of our time in Europe, I was at a very fulfilling workshop in Paris where researchers from Europe, United States, the South Pacific, came together to discuss this whole issue of the future of atoll islands. Because we have a problem which relates to what you said. Increasingly, development partners are saying, why should we spend development assistance to help people continue to live on those islands if they're going to disappear within the next few decades? So already some development partners, I won't mention them, are focusing their investments solely on the ability to relocate those people out of their island homes into metropolitan countries like Australia and New Zealand. And we, as a small community, are very concerned about this very narrow view of development, some development partners, because there is contrasting view of the future of these islands is that they have existed through periods of very rapid sea level rise in the past. Sea level rise for these atoll islands is not new. They've gone through high rates of sea level rise in the past, and they have natural process of building those islands. When you have a storm, the rubble from the reef is thrown up onto the land and becomes, in the longer term, habitable land. Not a very nice place to live for a while, but the society lived there, people lived there through those events and survived. They have that resilience. And the problem is that so much of development these days is preventing that natural process of island building. You build seawalls, you excavate all that rubble off the reef, crush it to make concrete. So we're spoiling those natural, or preventing those natural processes. So there are some real issues in that, but then if you look at the global issues about that you were referring to in your question about what do we need to do to convince larger countries that the future of these people is important reason for them to take climate change seriously, even if it's not going to have huge impacts for them. I'd answer that in two ways. Nobody is going to escape significant consequences of climate change. Climate change is not going to be selective. It's going to hit European countries hard, just like it's going to hit small Pacific Island countries hard. It may take longer, but it's going to happen. And so there is a need now to invest in those, in reducing our greenhouse gas emissions, so we limit those consequences, because the longer we wait, the more expensive, not just in dollars and cents, but in the wider sense of expense, it's going to be to address climate change. That's one answer. You're not going to escape it. The second answer is, as you referred, much more of a moral, ethical implication. And I don't think we should shy away from the moral dimension, the ethical dimension of climate change. I mean, we pride ourselves as a society living in the 21st century that we have these high values. That's what civilization is all about, improving our values. And when it comes to those values and the morals being tested, we fail, then to me that reduces the importance of our society and our civilization. we've been tested many times in the past, not by climate change, but by other challenges, and I think we've come through wiser and better. And climate change is another test. And I personally and humbly believe that we have, as a global community, to rise up to that challenge and show that, so that when we depart this world, and our children depart this world, and maybe our children's children's depart this world, our, what's the right word? Our opposite of ancestors, our future generations, thank you, sweet. Our future generations can not sit around a coffee table and say, look, my great-great-grandfather had the ability to leave us with a goodwill and he failed. I don't want to be up there. I think I'll be up there and have that on my conscience. So I really do see this as a yet another challenge for society and for civilization. And the IPCC can help us understand, and is helping us understand. There's a report coming out in the next week, special report on ocean and cryosphere, looking at the link between oceans and areas of snow and ice, particularly the Antarctic and Greenland. And that, I'm not allowed to say this, but that report will give us further reason to do something incredibly serious and have huge commitment to addressing this problem. Thank you.
Okay, so we really thank John. I have a last question for you, John, but because Roberto and I are experiencing now, the how big should be the effort actually to deliver the message as scientists to the society, to the citizens. So my question is, in your experience, in your long experience, 40 years of experience in this field, as a scientist, what did you find the effective ways to actually deliver the message, not only to policymakers, but also to normal people? Simplifying, a complex message like, the mechanism climate change, or trying to talk just to the new generation? In your experience, which are the ways that you find the most effective?
Unlike Ricardo's question, this is an easy one to answer. You have to speak the language of the people you're trying to communicate with. It's as simple as that. I have talked to people in what we call kindergarten, so pre-school, right up to senior citizens, many much older than I am. And I've talked to people with huge technical capabilities, way beyond my technical capabilities, or people with understanding of human ethics and moral issues, way beyond mine. But each time I've been able to connect to those people by speaking their language rather than relying on my language. I'm a scientist, and it's very easy for me to speak as a scientist. but I will have no impact when I talk to a young preschooler or a senior citizen in an old people home if I talk my science. I mean, I risked doing some science in here because I know I'm talking to some scientists, and I wanted to make sure that behind those general statements I was making was science. That gives me credibility. So I wanted to make sure you saw me as a credible speaker. But my effectiveness as a speaker is not because of my credibility. My effectiveness as a speaker is my ability to communicate. And in order to communicate, I have to speak your language. So, for example, why did I talk about the Pacific? For two reasons. One is that that's where I have my experience and my passion, and that's important to get across. But the other one was because our experience in the Pacific has direct relevance to coastal Italy. And therefore, if I could communicate that by speaking about things which you relate to, coastal flooding, etc., then I communicate and I have an impact. Simple question and answer.
I think we have a last question here.
Yes, thank you, John, for this talk. I'm sorry I have some other people in my room, but I was thinking why you're talking about this dramatic, let me say, situation that you described. A fantastic book that I read some years ago, that is The Limit to Growth by Meadows and Randers, and probably you know very well this book. That has been written in 1972 and was an exercise done by people at MIT with one of the first large computer facility in order to preview and have a forecast of which is the limit, the sustainability of the growing in terms of number of people, of technology, and use of carbon resources, and so on. And now we can see that that forecast was wrong, but some interest growth from that experience, very important experience. Now we again try to have a forecast of the future, but starting with something that is measurable with respect to that period. In that period, one of the difficulties was to understand how the boundary condition will change. Now we have some information about the feedback of our activities, and we can do some what-if analysis of. So can you give us a very short comment on what changed in our capability to have a forecast from that period to now?
Thank you. And you've reminded me of something that as a tool that I have been finding very relevant, again, partly as communicate, but just in my own work. And that is that in order to address issues like climate change, we have to go through a transition. We have to have hindsight, and we need insight, and those two will give us foresight. And it's really the combination and that pathway, hindsight, insight, and foresight. And studies like the limits to growth really provided us with a huge amount of insight as to how human society was existing in the planet Earth, and what were some of the consequences and what were some of the opportunities. Unfortunately, that particular study didn't provide us with good foresight, but by taking those hindsight and insight and improving those areas, we can have huge increases in our improvements in our foresight. And this is what various organizations are now doing, and your center will be absolutely focusing on that. So looking back in time, and the students I met with, many of them are analyzing the historic record and change processes. That provides the insight, and that benefit of that knowledge provides a robust scenarios and guidance for the future. And now we see that Commission on Adaptation that I was referring to at the end, the benefits of the understanding that had came through in that study provide us with guidance going forward. So I think we've learned a lot from, I wouldn't call them failures, but first attempts,
Sure.
Awareness raising. And then, of course, we need to always improve.
And those periods was started in Italy as a Club di Roma that started it.
Yeah.
It's in
Yeah, and that's where I guess it's important. International collaboration and cooperation is fundamental, and this is why it's been such a privilege to share with you today. So thank you very much.
John, this is more present for you.